Hello and welcome to yet another episode of Deconstruction Fridays. Now you see I'm doing a little vlogging here. Usually I have the camera set up and everything, but it's okay. Vlogging, it's not a bad idea. In this week's episode, we are going to continue talking about design patterns because those are very important as I have described in the previous week. So this week we are going to deconstruct Singleton design pattern. Now you may or may not have heard of Singleton. It's yet another amazing design pattern that is commonly used, and I think you should at least understand it. Very good. Without any further ado, let's get to it. Now let's go ahead and take a look at the Singleton pattern. Now, to understand this, let's go back to the basics of creating objects in Java. So, when we want to create objects in Java, what do? We use the new keyword. So, in this case, if we wanted to create a cheeseburger type, cheeseburger object, we would say cheeseburger is equal to new cheeseburger. So what are we doing here? Of course, we are using the new keyword, which allows us to call the public. That's very important to remember. This is a public constructor of our cheeseburger class. So that way we can actually construct our object. In this case, a cheeseburger. So if we wanted to create more than one cheeseburger, different objects, of course, we can use the same process. New cheeseburger 1, cheeseburger 3, 2, and so many more. Now, there's nothing really wrong with this process. In fact, this is the basics of object-oriented programming, creating objects and so forth. But one of the problems that we may end up having is that we may create too many objects, too many entry points that are not necessary. Now, there are times when we need the creation of all those objects, obviously, but there are times that we don't. There are times we only need one instance of a particular object. And the solution for that is Singleton. A singleton, by definition from the Gang of Four book, ensures a class has only one instance and provide a global point of access to it. So as opposed to having different instances of a certain class, a certain object, we now use, when we use singleton, we are saying we just want to get one instance of that particular class. Now you may ask, what would be an example where we would need just a single class? Well, in situations when you know that a certain class doesn't need to be instantiated every time that it needs to be called. For instance, if you are creating a system where you're putting together a log system, right? A class that would allow developers or the system itself to log out certain messages in the console, then you wouldn't need to have a constant creation of that log object, that log class, because that is just a waste, right? You just want to make sure you have a singleton, one instance of that class. For instance, another example would be if you're creating a settings class for an application, you don't need to have objects of the same type of preferences, right? Because the whole class or the whole system or the whole application would be okay with only one instance. In fact, it is important that it only has one settings class or instance as the application runs. That way there are no concurrencies issue. Okay, there's a lot of different examples, but the idea here is whenever you want to make sure that there's only one instance of that particular class, then you use a singleton. And of course, as the definition tells us here, it also provides a global point of access. Now let's go ahead and put all of this into perspective so we can actually see the benefits and how to create a singleton. Okay, let's do this. Okay, so I went ahead and created a new project. I call this Singleton Pattern. All right, so I'm going to create a new class inside of our package here. It's Java class. And I'm going to call this just my class, just for examples here. So, and I'm going to say create a constructor, a very simple constructor indeed, as you can see there. Now, the important distinction here is that we see that this one says public, because now if we go back to our main here and we want to create an instance, an object of my class type, we're going to say my class is equal to new, right? My class as such. Okay, so now we have our my class handle here object that we can use. Now notice this is only happening because we said in my class that we have a public constructor. Of course, even if we hadn't explicitly created our constructor here, Java would have provided one for us. Okay, but the key point here is that we have public. But what happens if I go and say private? Now we go back here, we have a problem because now we can't access, as it says here, we cannot access our constructor, which means we can't really instantiate or create an object of type myClass. Now we are telling the system that, okay, we don't want this to be instantiated as a new object. We want, however, to create an instance of this object. So how do we do that? Well, we go back to our myClass here, and then at the bottom, I'm going to say public static myClass get instance. Now this get instance here will have to return a myClass type. So I can actually go ahead and say new myClass as such. Of course, we have to return. Okay. So now, if we go back to main here, we can get an instance. We can say is equal to myClass as such dot get instance. Now we have an instance of our myClass. In fact, if we go back, because this is still a normal class, we can add certain properties. I can say, for instance, say string name. Okay, I'm going to have getters and setters here. Say myClass dot name is equal to class. This example, so at this point we have now created our first singleton. Okay, so we created our first very simple singleton. It's not complete, it's not bulletproof, but is our first singleton. So again, what we're doing here, instead of instantiating the way we usually do to instantiate objects, we are now saying that this class here will always have one instance of this class in the entire application, in this entire project. So what we did, we created a get instance method here of type class, which is myClass here, because that's what we need. And then we return our class, this instance or this object of this class here. Now, of course, we're not done here because the whole idea behind this singleton is that we want to make sure there's only one instance that is created at a time, right? So in this case here, anybody else can go and create this instance, right? It could be that in a memory we already had another instance of myClass running, and then this wouldn't be good because it's not going to be a singleton per se, right? So we can run into other issues. So what we can do now, we can actually create an if statement. So to compartmentalize our code again, at the top here, what we can do, we can actually create another static instance variable. Okay, I'm going to say private static. I'm going to call my class type, call this unique instance. Okay, so we have at the top, so we can now infer or reference it inside of our get instance. Well, now that we have our unique instance which is a reference to our myClass here, our singleton, what we can do now, we can put an if statement. I can say if unique instance is null, meaning it doesn't exist before we create it, then we're going to create it. That means now I can say unique instance is equal to new myClass as such. And of course, when you return, then we can go ahead and return our unique instance as such. So now we have bulletproofed our singleton class here. So now for sure, we will always know that when we run this, when we get the instance of myClass here, we will always have one instance, because if there's one already, then we're going to use it as opposed to creating a new one. Because now here we're saying if unique instance is null, only then are we going to be able to create an instance of our class here. Perfect. Great. So congratulations, you were able to create your first singleton class in Java. And of course, like I said, this is not language specific. So if you are using any other object-oriented language, programming language, you can also use these concepts, these patterns, and modify them to fit your language. Perfect. I'll see you in the next video where we're going to continue talking about other ways to really bulletproof the singleton pattern. Perfect. I'll see you next. So we have put together the simplistic way of creating a singleton. As you know, computers, devices have evolved in so many ways. And most of the systems that we will be working with, they will allow for multi-threading. Okay, so we need to account for that because we want to make sure that as we are creating these instances, different threads don't go and run the same methods. If you're running this code in a multi-threaded system, which most devices systems are, then we want to avoid the cases where different threads are running the same get instance method at the same time. And that would not be good for obvious reasons. So we need to figure out a way in which we can make it so that we don't run into those issues. And likely in Java, we have the synchronized keyword. By synchronize our method, we will then be code thread safe. What this means is this will only allow one thread to run the method at a time. So it will force every other thread to be in a wait or blocked state before it runs it. Okay? So that will solve our problem for now. So I'm going to go ahead and say here synchronized as such, and we have that problem solved. Let's just put it here. One thing that we have to make sure that we understand here is, although this is a good solution, but it should not be the solution that you will automatically go to solve this issue. Because remember, when we synchronize methods, that can be a little bit expensive, quote unquote, for our overall performance of our system, of our application. So there are other ways to minimize this overhead that we may encounter by using synchronized in our get instance. Okay, but if you know for sure that whatever system that you're building, whatever software you're building, the overhead is going to be minimal for using the synchronized, then it's okay. Go ahead and use it. But if you feel like this is probably not going to be the best decision in terms of overhead, then there are other ways to minimize this, to solve this problem, this very problem, and which I will show you in the next videos. So let's go ahead and do something in our main, back to our main here. So to prove to you that we're indeed creating single instances of our singleton class. For that, I'm going to create another class here. I'm going to right click, say Java class. Let's call this person. Very simple, nothing big here. Let's create a constructor, s out. In this constructor, I'm just going to say creating a person. Okay, nothing big here. So inside of our main, again, what are we going to do? Let's go and instantiate our person the way we always do. Instantiate objects, new person, as such. Now here's what I'm going to do. I'm going to system out here. I'm going to say object person. Okay, and what I'm going to do, I'm going to just go ahead and call person as the object. So what this is going to do is going to give us the address where this object is, where it lives. Okay, so let's run this. So of course we're going to get creating person because we're calling the constructor. Okay, and of course we still have our class. As you can see here, the class is giving this address my class and this gibberish here. So pay attention to this gibberish, quote unquote. Okay, this is the address to where in memory our my class singleton lives. Now here's what I'm going to do. So you notice that for person we have a different address as well. Of course they can't be in the same address, but check this out. If I go here and I say my class, again, say second class is equal to my class and use the get instance as we did before, look what's going to happen. I'm going to go ahead and system out again. I'm going to say second class. Notice again, my class has this address. Let's see what's going to happen. I'm going to save and run this. And look at that. My class, we are still getting the same address, which means we are creating actually only one instance because they all have the same, right? Because if, let me go ahead here and say second instance, which is not necessarily a second instance, but I'm just adding it there so we can see the difference. Because remember, this is a singleton, so it doesn't have second instances. But you can see it says here, my class, there is the address, exactly the same. So this proves to us that indeed the get instance, we're just creating one instance all the time. Right? Because if we go back to our my class here, we made sure to say if unique instance, which is the instance of this my class here, is null, then we create a new one. If not, we are never going to create a new one. We're just going to use what we have. That is the beauty of using singleton. Now, if we go ahead and call another person here, when I say another person here, second person, equal to new person, and such, and I copy all of this and say second person, what do we call? Second as such. Look what's going to happen. You notice for object person we have this address, and for second person we have a total different address. That means because we are just creating those objects, right? It's not a singleton. Obviously, we're creating different object each time we invoke the new keyword. I just wanted to give you a little taste so you can actually see what we're talking about here. And you can imagine if you're building really big applications that need to streamline memory usage and there's no need to keep creating different objects, then you can see that you're way better off using singletons. If there's a class, as we discussed before, that doesn't really need to be instantiated, right? We just need one instance of it to do its work, and it's our global. We always use that instead of each time we're using different objects. Okay? And I hope this makes sense. All right, perfect. I'll see you in the next video. All right, so now that we're moving forward into understanding our singletons and how to synchronize them depending on situations, how that it's not even a good idea, let's move to a different perspective here. The perspective of if, say, your application always creates and uses an instance of the singleton, or the overhead of the creation at runtime aspects of the singleton are not bothersome in a way, then you may want to create a singleton eagerly. So that's another way of us doing it. So the previous way was the lazy way. Now this is eager. What that means is that we are actually going to change our code a little bit here, which means we're now going to create an actual instance inside of our singleton. What that means is the following. When we do it lazily, if you will, we create a singleton, our lazy singleton here, we create the instance at the top, the instance variable, at the top, and then we instantiate it to return it inside of our get instance, right? But now what we're going to do, we're actually going to change something. We can actually add, say, is equal to new my class. Okay, so now we don't need this instantiation. So here, what do we need? We don't even need this anymore. We can just go ahead and comment that out. And we are just going to go ahead and also get rid of this, synchronize. We don't need that because that will take care of everything. And what we're going to do next, and now all we do is just return our unique instance that we instantiated at the top of the class. So this makes sure that we don't have to call the get instance in order for us to actually create or instantiate our class, right? Because the moment this is called, then we right away create the instance of the class. The get instance only returns what's already been created. So this is called eagerly. Okay. So let's call this. This is what we'll call eagerly creating singleton class. Okay. So of course we save this and go back here. All of this should run. I'm getting rid of all this, at least this part here, because we don't need that anymore. We don't need that either. Perhaps we don't need this either. All right, there we go. So if we give it a run, we should see things still working as usual. So we'll use this, but at least we know that our code will run, our singleton will behave safely. Okay, again, remember this is for those cases where you know that your application always creates and uses an instance of the singleton, or the overhead of the creation at runtime aspect of the singleton part of thing. It's not a problem. Okay, so that's when you decide to use the eager creation of a singleton. One thing to remember is just the difference is that we are eagerly right away creating the unique instance at the top as an instance variable, and we are instantiating it right away. And then the get instance already just returns what has already been done. Go ahead and think of a situation where you think creating your singleton eagerly is better than creating it lazily, or lazy creation of the singleton. Okay, perfect. I'll see you next. All right, so I went ahead and actually created a singleton class just to simplify a few things here. So essentially, obviously, it's the same thing as my class, but my class is too generic and it's getting a little bit messier. So you want to make sure that we start clean here. Okay, so I'm gonna just get rid of the my class. Okay, so I created a singleton class. Again, has the same thing where we left off at eagerly creating singleton classes. Okay, now the next third way of creating a singleton is called the double-checked locking. So this allows us to reduce the use of synchronization in get instance. Because remember, synchronization is a little bit expensive. It can be expensive. So we want to figure out ways in which we can actually minimize the overhead. So this is another technique, if you will, to create singletons that can behave the way we want them to behave. So the idea here is to first check to see if an instance is created, and if not, then only then we will synchronize, right? Because we don't want to just go straight into synchronization knowing that it's an expensive thing, right? So we want to check first. That way we only synchronize the first time through just what we want. Okay, so what we're going to do here, we're actually going to change a few things. What would be the best way to do this? So I'm going to go ahead and comment that out so we have our documentation here working perfectly. So I'm going to create another one. I'm going to say private, and I'm going to use the volatile or volatile. I don't know how you would pronounce that. I think it's volatile. So volatile, what the volatile keyword does, it ensures that multiple threads handle the instance of the unique instance, in this case variable, correctly when it is being initialized to the singleton instance. Okay, so just think of this as a way for us to say, okay, make sure that if multiple threads are happening, then the unique instance variable is going to be handled correctly with no issues. And then I'm going to say static, so it's going to be the same instance variable that we created here, and I'm going to say singleton unique instance as such. But now what are we going to do inside of our get instance? We're going to go back to the if statement here. We're going to say if unique is null, we check first, right? And then if it is indeed null, that's when we actually call this synchronized, and we're going to pass our singleton here, that class. Okay, so we're going to make it synchronized, and then inside I'm going to be able to, let me make sure it like that. Okay, and then here I'm going to also go ahead and say if indeed unique instance is null, only then will I create a new instance, like that. And then of course we return our unique instance. Okay, so there's a lot of if statements here, but it makes sure that we have that double checked locking. Okay, so we are doing double check locking. Okay, if it's null, then we synchronize the class singleton, and then we check again as we synchronize it to see if the actual instance is still null. If it's null, then we create our singleton. Okay, So we have three ways in which we can create singleton classes. The first one is the lazy way. As you can see, you just go ahead and create your instance, as we saw before. The second one is the eagerly creation, which means, as you can see at the top here, we create the instance variable and we initialize it right away, as you can see here, or we instantiate it, or rather, right away, and so that our singleton get instance will only return the unique instance, right? So the moment that the singleton is called, it creates right away our instance singleton, and then we call the get instance and it just returns that right away. The third way, which is the double check locking, right? So it makes sure that we first check to see if an instance is created, and if not, then only then we synchronize. Okay, this way we only synchronize the first time through and get just what we want. As you can see, this singleton pattern, design pattern, is very simple conceptually, but you have to be very careful because with simplicity, I guess we tend to get to be more aware of the responsibility that we are carrying, because things could go wrong, especially when it comes to synchronizations and thread safe and so forth. So you, as a developer, you have to figure out what works for your situation. So now that I gave you all the tools to understand this pattern, it's your job to figure out where you should use this pattern. Okay, and I think that's the challenge. So when in doubt, think about it and don't just do things because you have the tools, right? So there are times that you can just use the lazy way, as I call it, of creating this singleton pattern. And there are times that you need something more complex, such as the eagerly creation, or the double check locking, whichever works for your situation. Perfect. So again, go ahead and think of instances, no pun intended, instances that you can use the singleton design pattern. Very well. So how did that go? Did you enjoy it? So as you learn about design patterns or anything that we deconstruct, I think it's always a good idea to actually put things into practice and start thinking ways to actually use it, okay? If you don't want to go ahead and use it right away, you can look online and see perhaps other projects where they use these design patterns or whatever it is that we are deconstructing. So if you like this video, don't forget to like, share, and of course, if you haven't done this, to go ahead and subscribe to this channel. There's always great nuggets, great things that I'm going to show you, share with you in this channel, so you become a well-rounded developer, which is exactly what I want you to be. Very good. Thank you so much. Be well, stay well, and of course, code well.